Hi everybody, this is your instructor for the online C++2 class. I am making this video for the chapter 10, which can be found under the modules area. So we cover one chapter in 2 weeks. So this is how you can see chapter 7, and I have put this video lecture plus the assignment help for chapter 7, chapter 8, and chapter 9, similar to these for week 8. And week 9, I'll be posting an assignment 8 videos, which will include my video lecture and the assignment help for the chapter 10 items. It will help you with doing the quiz for chapter 10 and the assignment for chapter 10. And given that I have the access to the ebook, I can go over this with you so that you can understand the concepts covered in chapter 10, which is classes and data abstractions. In this chapter, we'll learn about the classes. We'll learn about private and public members of the class. We will not be covering protected right now. We'll learn how classes are implemented, become aware of the accessor and mutator functions, examine the constructor and deconstructors that are available in C++ for a class. We'll learn about the abstract data type briefly, explore how classes are used to implement abstract data types, become aware of the difference between a strut and a class. The strut is something that we learned last chapter 9. And then we'll learn about information hiding, explore how information hiding is implemented in C++ throughout this chapter. And finally, we'll touch briefly upon the static members of a class. So let's get going. So in last chapter, we learned about struts. Struts actually, as you know, it can allow you to capture different types of data elements together. If you're capturing information about patient, you need to know the name, the ID, the age, the diagnosis. Those things can be captured in a strut, and we can use it rather than declaring a variable for each one of them. Similar to that, we can also have classes. By the way, struts also allow you to have functions. So struts data items can also as well be functions, so please understand. However, that's a little complicated, so that's why we haven't covered that. The concept with classes is that classes does pretty much same thing as strut, but it has become a de facto standard in object oriented programming in all the programming languages. So whether it is C++, Java, C Sharp, or VB, classes are at the center of it. And how do you declare a class? You just use the reserve word called class, write the name, and then you have the member list. A class can have something as private so that no other class can use it, and can also have public that other classes can use it. So here is an example. We have course type and public. We are defining the function signatures and also any other attributes that we want to make public. And then you have the private. 99.9% when you're declaring a class, you will always have public functions or methods, and everything that is the attribute, the information about the class, such similar to the data items in a strut, will always be private. So nobody can directly access these things. Nobody meaning any other class that is using it. If you do not write the private and you just declare something, then those are automatically becomes private. So if a member of a class is private, you cannot access it. By default, all members of the class are private, which is what I mentioned to you. To make a member of a class public, you use the member access specify public with a colon sign, as we have seen here. And this is an example of private, and this is the example of public. Now this is the structure of the class. It is not the implementation of the class. You are not telling what happens when you call get course info, or what happens when you call get credit. This is just a signature. We haven't defined that yet. And there are multiple ways of doing that, as we will see. So here is the example again. We have a bunch of public methods. Some of them are returning void, which means they don't return anything. Now when you are having a particular function such as get time, and when you're supplying some information to that, you can actually manipulate it because it's part of the class. So these functions have access to these private attributes, these private variables, or of that class, and you can actually manipulate them. But if you want to prevent manipulating, then you actually don't supply them. You supply them as constants. And also, if you want to prevent this whole function from doing any kind of change to these private variables, then you use the const outside of the parenthesis as shown here. But if you want to prevent anything happening to the variable or any information sent to the function, then you also write this const, which is, excuse me, which is shown right here in this example. Okay, we will be covering that as well in the coming pages. You can have the private and public in any order. It doesn't matter. You can write public and then define everything, or you can write private and define everything. Okay. Just to reiterate on the const word that you spotted here as well as here, we can see that the word const at the end of member function get time, print time, and equal time specified that these functions cannot modify the member variables of a variable of type clock type. So this is talking about the const outside of the parenthesis before the semicolon. It's telling that these functions cannot mess with the information in the private member variables. That means we are trying to lock them, and these functions, even though they are public, if somebody calls them, they cannot modify any information. Okay, let's go to the next page. This is how you may define a unified modeling language for a class. You have a clock type as the name of the class. You have the integer variables for hour, minutes, and second, and then you have functions which are defined as shown in the figure below. Variable declaration or object declaration. So a class is a representation of something that is similar to a noun. So a noun has, some attributes such as a human class will have human name and SSN and the age and date of birth and stuff like that. Age may not be a variable. It changes continuously. So your age depends on what day it is today, right? So that is a implementation. That would be a function which would say on this human I want to get the age, and to do that you will see what is today's date and what is the date of birth of this particular human or instance of that human, which we call object, and then we will calculate the age as of that moment. Okay, so how do you declare a variable of a class? You type the class name and then you define whatever name you would like. So here we are saying clock type and my clock and your clock. So there are two variables we are declaring for our class. We can do that in the main method right there in the class where we are writing, or we can call it in a different class altogether. Okay, we can write a main uh, code as we have done for prior chapters, and then utilize this clock type class by including it, just like we include the IO stream and other header files. So if we declare two variables, this is how it will be. There will be different spots given in the memory. If you want to access the hour, and provided hour is a public, you would use class name dot member name. Now, if the hour, minute, and second, as we have seen in the previous pages, they are private attributes. So therefore, we cannot directly type my class.hr or my class.min for minute because they are private. You need to have what is usually referred as the get method or the set method, getter and setter. Okay. But if you have to access a member which is public, whether it is a variable or whether it is a function, you would use the class name dot member name in general. So here we have two variables of clock type, and then we are saying my clock dot set time, and we are giving the time, and we are saying my clock dot print time. So these are public functions, public methods, and therefore we can use them. Similar to this, you can also write my clock dot equal time equal to your clock, where you are going to compare the private member variables of your clock with my clock to see if they are equal or not. Okay, because like I said, if the hour, minute, and second are private, you cannot directly set the values like this because these are private, and therefore only the members that are within the class have access to this. You cannot directly call it on an instance of your class such as my clock. So what can we do as a built-in functions on classes? Most of the built-in operations do not apply to class. We have to implement them there. That is what we have mentioned here. We cannot compare two classes just side by side. We cannot compare like arrays and strut as we have learned in the prior chapters. So we have to implement those things if we want to compare one with the other. We cannot say my clock equal to your clock, because these are different variables in the memory, and therefore those memory locations will equate to false all the time. So we can never do this directly unless we have done some extra work. A class object scope, when you declare a class, it can automatically creates an instance of the class when you're using it, and when you're done with your main method, for example, the class will be destroyed. So the amount of memory allocated will be destroyed when you are when you the function in which you're calling the class variable is finished. The following rule describes the relationship between functions and classes. Class object can be passed as parameters to function and return as function values. So we can pass a class object to a function as well as return from it. As parameters to function, class object can be either passed by value or by reference, as we will see shortly. If a class object is passed by value, the content of the member variable of the actual parameters are copied into the corresponding member variables of the formal parameter. That means what goes inside the function, so that the values of the original member variables for that class cannot be modified. So here we have an example where this test time is a function. It returns nothing, but it accepts a variable of class type clock type, which is shown here. But because we want to stop this function from manipulating the values inside this, we are passing it as constant, which prevents it from changing it. Okay. Um, Implementation of member functions. So when we are implementing the functions which we have defined, we will be using the name of the class, such as clock type, double colon, which is scope resolution operator, double colon, as you can see here, and then we will implement it. So if we are getting three integer variables, we'll say if the hour is less than equal to 0, and hours is uh, if the hours is more than equal to 0 and hours is less than 24, then we will set it. Otherwise, we'll set it to 0. So whatever implementation is needed, we can do that inside the function, and this is an example of the implementation of the function. As you can see here, it doesn't return anything, so there is no return keyword, and it has the word void, which explicitly tells that this function does not return anything. Here is the example. If we declare a variable of clock type by calling it my clock, and then we use the set time when we run this line, then this is the outcome which will happen, because we are depositing those three integer values into the member variables by setting the values to those. If we are using a get time, then we are getting the time. So we are supplying three reference variables: hours, minutes, and second, and it's a constant, so it cannot manipulate the member variables inside this function, no matter what is sent here. So here we are taking the hours and we are setting it to HR, which is the hour for the member variable. We are just accessing it. We are not changing it in any way. Similar to this, we have another function, print time, which is by using the word const here, we are telling that this member function cannot manipulate, cannot mess the values for the member variables, any of the member variables. Primarily, we are interested in the private member variables. Therefore, we are just saying if the hour is less than 10, then display 0, cout 0, and then write the hour, which is 01, 02, 03. If the minute is less than 0, similarly do that as well. Increment hour is another function, and this is how you would implement it. It's a void function. It doesn't return, it just increments the hour. And if the hour is more than 23, it sets it to 0. So this is how it is being done for this example that we are seeing in the textbook. For the equal time, which is checking if the values in one variable of clock type is equal to another, we are supplying another instance of clock type class, and we are saying, hey, return if the hour in this class is equal to the other clock hour, and the minute is equal, and the uh, Second is equal. If all three are equal, then it will return true, otherwise it will return false. This is how you equate, you compare one uh, class variable with another. And this is an example. If my clock dot equal time your clock, then it will return true. It will do what the logic is, otherwise it will return false. Kindly go through some of these points that I mentioned here. The hour, minute, and second that are declared as private member variables are called instance variable. This is usually the term you will hear people use in Java, C++. Accessor and mutator functions. So accessor functions are the function that allows us to access the variables within a class, and mutator functions are the function that modifies the value of the member variable. So you would use the word mutator when you have to manipulate the values within the member variable. Otherwise, most of your functions will be accessor functions. Okay. When, as we have learned in the past, when the member function of a class contains the word const, such as this get time and equal time and print time, then they are called constant functions. That means we are telling that this function cannot change any values no matter what is coming in, and we would like to prevent any manipulation for the member variables inside that function. So that's a very important keyword you should remember. Here we have an entire example. So we are saying, okay, we are going to have IOStream. We have a class. Here is the definition. Here is the signature of the class. And then we have the int main where we are declaring two variables. And then we are calling the set time. We are calling the print time on it. And then we are doing the other things as well. So we are assuming that all those member implementation for different functions is shown in the previous pages are given, and the outcome from this will be displayed as follows. Now kindly note that for line 5 your clock will display a memory location which might come different than what you are seeing here if you were to write this code and run it. Okay, kindly look at the print time function as it will help you learn about the significance of what I am telling you right here. Order of public and private members of the class. As I mentioned to you previously, there is no order. You can write public first and private next, or vice versa. This is just the original thing that we have seen, or you can write the private first and then you can write the public next. If you do not write anything, then these become automatically private, as I mentioned to you in the past. What is a constructor? A constructor is the way of initializing a class. If you don't write a constructor, then C++ automatically provides you with a constructor. And constructors are the functions which are special in nature. They don't use the word void, and the name of the constructor function is the same as the name of the class. If you have a constructor, you can have more than one constructor, but if you have more than one constructor, they have to be different. So here is an example where clock type int. This is a constructor which takes 3 parameter, and clock type, which is the default constructor. If there is nothing, then C++ automatically provides you a constructor which is called automatically, whether you have implemented that or not. But as you can see here, we are using two constructor. The name of the constructor functions is exactly same as the name of the class, and please understand, as you have realized, the C++ is a case sensitive language, so we have to be very careful when we are typing something. Okay, constructors have various properties. As you can see here, it doesn't use the word void. It has the same name as the name of the class. Class can have more than one constructor. If the class has more than one constructor, the constructor must have different formal parameter list. So here we have 3 parameters coming in. Here we have nothing coming in. When we declare an instance of a class, the constructor is automatically called depending upon which signature we are using. So which is what is mentioned in these last 2 points you are seeing here. Okay, which constructor execute depends on the type of value passed to the class object when the class object is declared. We will see a definition of this or a usage of this shortly. Here is the implementation of the clock type. constructor, it is getting three variables, and we are using the if logic to set the values for the three member variables, three private member variables. We can also write the default constructor where we can say, hey, I'm not going to get any formal parameters, but I'm going to set the hour, minute, and second all to 0. So we can also say, hey, when you call the constructor, I'm going to call my public member function, which is set time, and I'm going to set it. How do you invoke a constructor? When you write this line, as we have seen, when you say clock type, your clock or my clock or his clock, you are actually calling the constructor. If you have written, it will execute. If you haven't written, then C++ provides you, which is an empty constructor. It doesn't do anything by itself. But in this example, this is the constructor that will be called, which takes no formal parameters. So hour, minute, and second will be defaulted to 0 when you call this one. Invoking a constructor with parameter. And by the way, when you're declaring a variable, you don't put the open and close parenthesis. That would be illegal, so you cannot type this. If you were to call a constructor which takes the argument, you would call it like this. You will say, hey, I have a class called clock type, and I want to create an instance of that called my clock, and I'm going to use the constructor which takes three parameters, and I can pass it like this. So you can have many constructor with different formal parameters. If they are different, then the constructor will be treated differently. Or you can, here is an example. We have inventory, one constructor, another. So basically we are saying we have four private variables. You can set nothing. You can send me one and I'll set one of the variables, which is string here, and then you can send me two, or you can send me this. So you can have multiple constructors. One which takes nothing will do like this. The one that takes string will set the name, and rest of the private member variables will be set to some default values. As you can see here, there are three values being sent, and units in stock is set to 0, which may be driven by the business logic. And here we have another which takes all four, and we can set all four, and here's how you would call it. Constructor and default parameters. So you can call a constructor which can be define a constructor which takes three integers, or define a constructor which takes nothing. You can imagine that when you're having something like this, it'll become quite cumbersome. You will have lots of constructors. So you can prevent that by having a signature line like this, where you are saying, I have a constructor which can take up to three integer parameters. If you send it, good. If you don't, no problem. If you have just this one line like this, then you can, this is a legal statement, and legal statement. So all of them become legal, and you only have one constructor where you are getting up to three integer parameters, formal parameters. Classes and constructors. If a class has no constructor, then the object created is uninitialized. That means C++ does not automatically initialize the variable when they are declared. Um, in reality, if a class has no constructor, then C++ automatically provides a default constructor, which is what I mentioned. However, this default constructor does not initialize the object being declared. That means your hour, minute, and second might have random values in them. So it's always a good idea to have a default constructor if nothing. Here we have a constructor which takes x and y, and it will set the values. So if you have my object 10 and 5, it will set, probably given the implementation, dx will set the x and dy will set the y. So this is an explicit implementation of a constructor. Inline initialization of data members and default constructors. So we can also define the default constructor and the data initialization, such as the following. So we have a constructor which is coming in with three parameters. We can call my time as follows, and your time. Both of them are legal statements because we have in. So we can have this and this. Now kindly note that, as mentioned in this one paragraph, here we are not saying my class has a constructor which takes no parameter. So how come my time is going to work? Well, it depends on the compiler. Sometime The default constructor, if you don't write it, then it will result into an error, but otherwise it might run successfully. So I would say whenever you're having a class, have a constructor and use that exact constructor. So in this case, we will have clock type, your time, and we'll pass the three integer parameters. This top line is not advisable unless you have a constructor which takes no parameter. So keep that in mind. Can we create an arrays of classes? You bet. We can just do it similar to how we can do for struts. We can create an array. And how do we access the elements? We'll just say arrival time m 0, which is for the first element, dot set time, dot get time, and something like that. So every element in the array is an instance of a class, and this is exactly what I was telling you. For the 50th element, we want to set time, and it will set the time like this. Another example of how we can use a for loop to print the time for all the elements in the array from 0 to 99 position. How can we write deconstructor? Deconstructor follows the same pattern as constructor. Deconstructor is used to destroy the values of the member variable. And how do you write a deconstructor? You use the tilde sign, which is a squiggly sign followed by the name of your uh, class name, as all the constructors and deconstructors have the same name as the class name. When we are writing classes, we don't combine the design and the implementation in the same file. We try to keep them separate, and that's what we call abstraction. Separating the design detail from how it's used is called abstraction. And abstract data type is a concept, a data type that separates the logical property from the implementation detail. It's a concept, where we are saying I have a class. How What it does is given to you, but how it does is hidden. We don't show it. This is what we call abstraction. So the abstract data type has three things: the name, the domain, and operation. So an integer variable will have a name, it's int. Domain is what is the range, and what operations. You can do add, subtract, multiply, divide, remainder operations. So we have a data type clock type. What is a domain? Each clock type is a time of a day in the form of hour, minutes, and second. And what operations you can do? Here's the detail, which we have been seeing for all these pages. Another example is shown in 10.7. So given the abstract data type, as a concept, it's not something you do it, but this is what you will define. You'll say, hey, here's the implementation of my abstract data type. I have a class. It has public member variable, member functions and private member variables as shown here. And this is what you will define, which is not different. Strut versus a class, as I want to keep it short, struts are basically a good way of implementing the details, but when you have to do some manipulation on the data, you tend to basically utilize classes more than struts. It's not to say struts cannot have functions, struts can also have functions, but classes allow more flexibility, and classes become the standalone de facto standard for implementing, real life problem solvings in all the programming languages. So kindly compare briefly about the differences between the struts and classes as shown here. Information hiding, we have been talking about this concept all along, whereby a class can have private member variables and by utilizing the word private. So that is pretty much, what's mentioned here with regard to information hiding. Similarly, when we were talking about abstract data type, how I mentioned that we want to define the signature of the class, but not disclose the implementation of the class. And we do that by defining the structure of the class. What are the private and public member variables in the class in a header file .h file. The header file has the signature, but we implement it in a separate file. So when we are writing the signature, we will save it as .h file, the header file, and when we are implementing it, we will implement and save it in a .cpp file. and we will have to use the name of the H file, the header file, inside our implementation file. Similarly, if I have created a .h file for class type, and I have also given you the object code, the byte code for my implementation class, you can just say include clock type.h in your main code, and then you can run it. So here is the example of the clock type.h, the header file, or this is just the signature of how what my class has. It has some information about what is the function does, what are the post conditions, so that somebody who is reading it can understand the meaning of this. Okay. And when we are implementing it, it will be totally different. This is just the signature. And here we have clock type imp.cpp, where we are importing our header file and we are writing the implementation of that. So when we are using these, we'll just be importing the header file because we don't want to know the implementation, or we don't want to share the implementation. That's to save your code from somebody messing with it, as in doing something harm to it. So you would create, executable code for your header file as well as your implementation file. But when you are writing your code with the main method, you will basically import the header file, and you can totally use the uh, implementation automatically. Now, this is what you see here. If you read through these few lines, you will understand how to do it on a command line. But if you're using Visual Studio, or any other IDE, these things with building and rebuilding and making of the code is totally transparent. You don't have to worry about it. It happens very, very easily behind the scenes. So here is an example of the header file, and the implementation is totally different. So one can define the structure and somebody else can write the code for it. And this is how you would use it. You will import the circle type, you will create an array, and you will have another one, and you can use the public functions that are provided and display the information as need be. Here is another one where the rolling of a dice is implemented separately from the header file, as you can see here. And here is the implementation, and how do you use it is given here. These are very small code. Now, mind you, with chapter 10 code, you will have multiple items in your project. If you're using Visual Studio for coding, you'll have a header file, you will have a class file, and then you will have your main file where you are using the header file and internally the class file to do something. Okay. A couple more examples are shown here in the subsequent pages, very similar to what I have talked to you about it. We have the header file up above, and we have the implementation down below, and then we can use it in another one. One more example shown here, that if you're given a string like this, an integer value like this, you can count how many are odd and even, and you can reverse it and things like that. So how many zeros are there and stuff like that. You can add the digits inside that, which is shown here. This is just an example to get your mind going. Okay, this is the implementation, and how to use it is shown below. I would highly recommend, write one header file, one class, and use it, because it will give you a great level of confidence in using this. What about the static members of a class? Well, when we are having a class like clock type, and we create an instance of clock type as my clock and your clock, then I can use set time on my clock to set it to 111, and you can use your clock type, which is your clock, to set the time to 222. And we are given separate memory locations where we can store this information separately, which is where the static comes in. The static members of a class are not given individually for each instance of the class. Static members are given a single location, and all the instance variables share that. So if a function of a class is static, in the class definition, it is declared using the keyword static. If a member variable of a class is static, it is declared using the static keyword, which can be seen in here. So here we have a public function called static int count. This is a member variable. We also have static void increment y, which is a static, and we have a static int y. So we are using the word static in the beginning. Now, if we declare, if we just say illustrate colon colon count equal to 0, this is totally fine. If we say in illustrate colon colon y equal to 0, this is totally fine. Even though illustrate is the name of the class, we are not using it with the name of the instance variable. How come it's working? Well, this is how you access the static variable. You can also use the name of your variable. You can say my illustrate colon colon or dot count equal to 0, which will also be totally fine. Examples of the same point that I was telling you about. So if you have an array of illustrate with three items and another one with 5 items, we can see that the static variable are kept in a single memory location, and it is used by all the instances of your class. These are not given for each instance. Kindly keep that in mind. Okay. Here some more examples illustrating the same point about the concept of static. Again, you can call the instance the static functions utilizing the name of the class, or you can call the static functions as on line 8 using the variable name. So here we are using illustrate colon colon increment y, which it can also be written like this as I mentioned to you in couple of pages ago. Kindly read through this briefly so you understand the total meaning of how a static function is used. Now, kindly note that if you have a static function, it cannot use non-static member variables inside. So a static function cannot use non-static member variables because a static function can be used without declaring an instance of a class. So if you don't have an instance of a class, how can you use the member variables that are individual to each instance, which is what this note is talking about. Okay, please read through these. These are very important concept for your overall understanding of object oriented programming as well as on the concept covered in chapter 10. With that, we have a programming example given in the book. Probably you can download the code from the website as well for this juice machine. This is a comprehensive uh, project that they are provided to you, so you can assimilate everything that I have mentioned in this video. There are various signature as well as implementation of the functions of the classes of the constructors, which you can see here. I'm not going to go through this because this is more of a summary, so I'm going to skip this and reach it to the end of this. The entire code is given to you. You can write it in a matter of few hours of your time or even less, how it is doing everything. With that, we are at the review of this chapter. The chapter 10 quiz can be done easily. All the points I mentioned will allow you to thoroughly complete this chapter 10 quiz, provided you also have read this chapter on your own to understand the different points covered in this chapter. For chapter 10 assignment, you're asked to do exercise 6 and 7 on page 722. So let's go to the page number 722 and look at the exercise 6. So this is page 722. Consider the following declaration 1, 2, 5, 7. These are the different topics covered in this exercise. So we have a class called backtype. We have public functions. We have 1, 2, 3, 4, 5, 6, 7 public, and then we have 1, 2, 3, 4, 5 private member variables. So 7 plus 5 is 12, and we are declaring a instance of backtype, calling it new bag. You're asked how many members does class backtype have? The answer is 7 plus 5, 12. How many private members does class backtype have? You can know that I was counting earlier, 7. How many constructor does class backtype have? How many constructors do you see? Constructors are the functions which share the same name as the name of your class, and it is back type. So we have two constructor. How many constant function does class back type have? Let's see. Count. We're talking about print, get style, and get price. So we're talking about three constant functions. Which constructor is used to initialize the object new bag? The new bag, because it is not having any parenthesis, it is using the default constructor. So these are the questions that you have for the exercise 6. You have the answers here as well, briefly. Assume the definition of class backtype as given in exercise 6 and answer the following questions. Write the definition of a member function set so that the private members are set according to the parameters. So we are asked to implement this function, and it is taking string double as the formal parameters. How do you use these and set the values for your member variables is what you are asked to do. How do you write the implementation for the set? You will use void backtype colon set, and then given these values, you will set the values, which would probably look like this. You will write void, and then you will define the implementation for the set function like this. You are saying, hey, I'm going to call it S and A, B, C, and D, and given those values, I'm going to set my private member variables as follows. How about B? Write the definition of the member function print that prints the value of the data member. The print is right here. How do you write it? Again, you will use like this, where you're saying I have void because it doesn't return anything, the name of the class colon name of the function open close parenthesis const open per curly brace, and you're just displaying the output of the five member variables, private member variables, style, L, W, H, and price with an end line. Number C, write the definition of the default constructor of the class backtype so that the private member variables are initialized with blank, which would look somewhat like this. You will have a backtype colon backtype, and you're just setting the value. Default constructor. Write a C++ statement that prints the value of the object new bag. So you say new bag dot print, which is print the output or the information about the new bag, and write a C++ statement that declares the object temp bag of type bag type and initializes the member variable of the temp bag to backpack and so on. So how many parameters are passed? 1, 2, 3, 4, 5. Because we need to set it to 5, we can use this constructor rather than typing bag type equal to temp bag. We'll say temp bag in open and close parentheses. We'll specify these 5 parameters, which would look somewhat like this. So this is how it would present in your code. Hopefully you can see that what I'm showing here and answer these questions. So these are the exercises that you have to do for chapter 10, the number 6 and 7. I highly encourage, these are fine, but you can also try to implement one of the header files, one of the class files. So you build confidence in writing classes and working with constructors, deconstructors, static member variables, static member functions, and learn more about abstract data type. Hopefully this video has given you some idea about chapter 10. I'll be posting the link for chapter 10 video lecture and assignment help right here in week 8 as well as in week 9 shortly. So do make use of these, and if you have questions, let me know. I'm here to help. I would like to provide as much assistance as you need so that you can succeed in this class as well as in your programming endeavors. Thank you. Have a great day.